So let's do another projectile motion problem. Suppose we have a building here, okay, and to make this easy, let's say it's a flat roofed building. The height of the building is going to be 19.6 feet. And we have someone standing over here, and they are a distance of 25 feet from the building, and they throw something upwards with an initial velocity of 41.7 feet per second at an angle of 62 degrees from horizontal, and the initial height is going to be 5.1 feet. So 5.1 feet. And so what I want to know is, where does it hit the top of the building, and what direction is it moving when it hits the top of the building? Okay, so we look at it and we can say, well, we know that x equals x naught plus v x naught t plus 1/2 ax t squared. We know that y is y naught plus v y naught t plus 1/2 ay t squared. And so we know that gravity is going to be straight down. We know there's no x acceleration. What I can do is I can put my origin right here and say that x naught is 0. That would make y naught 0. Means the final y is going to be 19.6 minus 5.1 feet. And so that will be 14.5 feet. So that's going to be the final y. So that means I know this. Okay. From the origin, I know what that's going to be over here. From the original data, we can find Vx naught and Vy naught. Okay. So Vx naught is going to be 41.7 feet per second times cosine 62 degrees, which is 19.6 feet per second. Vy naught is going to be, Vy naught here, okay, is going to be equal to 41.7 feet per second sine 62 degrees. And that is going to be 36.8 feet per second. Okay, so we got everything, and we realize, okay, we know everything in this equation here to the right. We can solve for t, plug in over here, and that will tell us the x distance where it hits. Okay, and then we can use the velocity equation to find the direction and speed. Okay. So, the y equation now looks like Vy naught t minus 1/2 gt squared. Okay, if I say up positive, then g is going to be negative. So 1/2 gt squared minus Vy naught t plus y equals 0. Okay, so quadratic equation. So t is going to be Vy naught plus or minus square root Vy naught squared minus 2gy divided by g. Okay, so Vy naught 19.6 feet per second plus or minus the square root of 19.6 feet per second, then that quantity squared, minus 2. Now we're doing feet, so you have to use 32.2 feet per second squared, 14.5 feet, because that's how above his hand it went. Okay, divided by 32.2 feet per second squared. Now, once again, I'm doing a problem here in British imperial units, so once again, you have to use the right G, 32.2, not 9.81. Okay, I'm doing this intentionally to get you practice thinking about that. You have to look and see which G you use. Do you use 9.81 meter per second squared, or do you use 32.2 feet per second squared? And so you have to look and see what units are in the problem. So there's two possible answers here. The two answers are 0.506 seconds or 1.78 seconds. All right, so before, when we did a problem, we had a positive and a negative number. We need to throw away the negative number. Now we have two positive numbers. So what's going on? Well, imagine what's going on here. You're throwing the ball upwards and it comes down. So we're looking for when is it at that height? Well, it's at that height twice, once on the way up, once on the way down. So obviously the first number is the way up. The second number is after it's reached its peak and it's on the way down. So that is the one that we want. So 1.78 seconds. Now, you have to be smart enough to figure out which of those two numbers it is. Okay, so now we have the number. We know that x is going to be Vx naught t. So x is going to be equal to 19.6 feet per second times the 1.78 seconds. Okay, so x is now going to come out to be 34.9 feet. Well, if we remember, 34.9 feet from where the person started, but the person was standing 25 feet from the edge. So I want to know how far from the edge up here. So that distance D right up here is going to be 34.9 feet minus 25 feet. So in other words, that's going to be 9.9 feet. So it lands 9.9 feet from the edge. So that's the first thing I asked for. So that was part A of the problem. Part B of the problem was when it hits, what direction is it moving? How fast? So I want to know the vector V. Okay. Well, I know that Vx is Vx naught plus AXT. Vy is Vy naught plus AYT. As before, the only acceleration's down, so that's 0. So Vy is just going to be Vy naught minus GT. Okay. So the x part doesn't change. So the Vx stays 19.6 feet per second. But the Vy is now going to be 36.8 feet per second minus 32.2 feet per second squared times 1.78 seconds. So Vy is going to be a negative 20.5 feet per second. So Vx, Vy, so the total V, square root Vx squared plus Vy squared, that comes out to be 28.4 feet per second. The angle is going to be the arctangent of Vy over Vx. And so if you plug in those numbers, that's 46.3 degrees. So we would say that V, when it hits, is going to be 28.4 feet per second in a direction that is 46.3 degrees below horizontal. Okay, so there we have it. There's the answer.